What's up everyone, welcome to Profit-3. So today exactly I'm going to talk about this quantitative finance, predicting stock prices and trading strategies in Python. Okay, so I've been already done 2 parts. Please go visit Profit-3 and watch the 2 videos. First one is introductory, and in second I've been explain further things about this unit circle and number plane, Cartesian coordinates, polar coordinates, okay, and each and everything in detail. So second part is necessary for the installation of our library and for further this part. Okay, so first and second videos is most important, so please go ahead and watch that. Okay, so we will definitely gonna move further for whatever we have done in previous. So whatever we left off, we will go for that thing. Okay, so I've been already explained things like cosine and sine. So we already took this part as an unit circle, and I've been explained like how we are going with the cos theta and sine theta, and what is hypotenuse, and how we are taking this unit circle. Okay, so these are very much necessary. Okay, and in that case trigonometric functions are very much required, okay, to understand further things how we are going. Okay, so today we will definitely gonna derive certain things, and we see to that what needs to be done. So in mathematics the trigonometric functions, okay, are real functions which relate an angle of a right angle triangle to ratios of two sides length. Okay, so we'll I've been already explained in this unit circle itself. So this is a right angle triangle, and I already told you this is very much important. Okay, so if I talk about this right angle triangle, as you can see, we are dealing with this part. Okay, and how we take this right angle triangle and derive or sine, cosine. Okay, so we'll deal with our this formula which we are dealing. So right angle triangle definitions. So what are things which we gonna do it right now? So what are sine theta, what is cosine theta? So all of things is gonna deal with this part, okay, which have been already done. So let's take this part and I will explain you how we are dealing with these things. Okay, so first let's create a right angle triangle. Okay, so you already know that right angle triangle it consists of a 90-degree. Okay, when we say, especially like when we go with the hypotenuse line, okay, especially it consists of angle, okay, and especially this we consider as an sides. Okay, this it's itself an value, so we can consider this as an value itself. Okay, so that is also can be done. So say suppose if we go through this right angle triangle, when we are dealing with this one, this is very much important. Say suppose when say suppose if you take a if I talk about a real life application, so if you take a real life applications, and if you are considering, say suppose if you are considering a tree or tower or a building, and you want to consider their height. Okay, so it is it is if you consider by theory, okay, and if you just go and watch, you can't consider what is the height of the tower or tree. It is need to be measured, and practically it is not possible to just go and take a tape and just measure it. Okay, so some of the things which you need to consider, so if you just having some idea about the angle and length, you will be easily measure the height of this one tree or tower. Okay, say suppose if I talk about these things, okay, so suppose this is height of my tower. Okay, and what are the things which I am considering right now? So suppose this is our angle. Okay, and when we are considering the angle part, okay, this should be like we can consider them. Say suppose if I am considering this as an 60 degree, this is our 60 degree. Okay, so suppose this is a 60 degree, and so suppose if I am considering this right angle triangle. So if you are considering this right angle triangle, you always know this is a 90 degree. Okay, when you go for a certain thing, this is always a 90 degree. Okay, now if I consider, say suppose if anything is there, okay, 5 feet, 10 feet, or any say suppose if a tree or tower is there, definitely a shadows will be there. from shadow from this point what you are doing. So suppose a point will be there. So from this that if I say that 60 degree, so what is our tan 60 degree will be there, which will be like our degrees. So tan 60 degree, if you calculate, it will be √3. Okay, so I got this value. Okay, so I'll give a formula on this one. So this is 90 degree. Okay, so this is our hypotenuse. Okay, this is our adjacent, as I said, like in our previous video. Okay, and this will be opposite. Okay, now how we say this? We say as in sine. Okay, this we will say as in cos. So especially when we are trying to find these things, okay, you can take as per your wish. Okay, now this 60 degree can be taken from this, any angle can be done. Okay, it's not a problem, and you can give any of feet height or whatever. Okay, so suppose if you will give somewhat like 50 meter or 55 meter, so it can be taken as that one. Okay, so now as I know, this we call as an P as an point. Okay, this we called as an origin. Okay, and right angle triangle can be moved any side. Okay, as I've been erased something, so that is also from that point also can be considered. So this I will say as in mid. Okay, so now we allot a formula, as in we require this PM specially. Okay, so we already got this one. So we have to say about this PM and by OM. Okay, now what happens, we got the value of OM. So what we say, PM by 50 meter. Okay, so whatever we got value. Okay, so now what happens, we got this value, and this is √3. So it's obvious, you can do it as this way. You can say okay, so you can do it this way. So you can say as in 50. Okay, 50 into whatever value is there. So suppose tan 60, you can say as in tan 60 itself. Okay, but we already got the value, so we will say 50 equals √3. Okay, so this is this will be our value of PM. So this is our height, 50 √3. Okay, so this is how we get the value. Okay, and any of things will be there. So suppose tan 60, tan 40, and any of, say suppose you got the hypotenuse, okay, here, and opposite and adjacent will be there. So you can take an angle from anywhere and can calculate from that point. So right angle triangle is very much helpful. So just a right angle triangle from any side, okay, from any way, if you try to calculate, so it will be very much helpful. Okay, so this is how you should follow something. So this is how we get to know about, and getting this tan itself, a tangent line will be there, which will study further. So this is how the trigonometric functions work. Okay, so this is what we are taking here, the considerations. Okay, I'll see to that, we'll see and try to derive the formulas. Okay, so we'll see. Okay, so right now you can consider this two side of our triangle. This is a triangle and this should be a triangle. Okay, so now if I say this is our this will be an adjacent, this will be an opposite, okay, and this will be an hypotenuse. Okay, now if I say that I have to derive this sine, okay, so sine theta equals A by C. Okay, now if I say theta means, here it is theta. Okay, so now if I have to say this sine theta, okay, so how we'll say this sine theta, then it will be like opposite by hypotenuse. Okay, so it will be PM PM by OP. Okay, now if I have to say cos theta, so it will be adjacent by hypotenuse, so I will say OM. Okay, OM by OP. So OP remains the same. Okay, so this is how we do. So this is the connection between our polar coordinates and rectangular coordinates. Okay, so this is how we derived. Okay, and same as with this sin theta cos theta we got. So we know sin theta by cos theta will be tan theta by cos theta will be our tan theta. Okay, so how it should be, tan theta should be there. Okay, because we are considering y by x, so it should be PM means opposite by adjacent OM. So this is our tan theta, and you know the value which we got for sin theta and cos theta, that's how we derived. And if I say the value of x, then it will be consist of our, so suppose if we are talking about the polar coordinates, so it will be r cos theta. So r means OP, and y equals should be r sin theta. So this is how we get to know. So this is how we considering. Okay, so if we try to divide by this thing, so what I'll say, there is a mnemonics, famous mnemonics is there, SOHCAHTOA. SOHCAHTOA. Okay, so if I get about this SOHCAHTOA, okay, so this is, so sine formula will be opposite by hypotenuse, and cosine will be adjacent by hypotenuse, and tangent will be opposite by adjacent. Okay, so this will be your formula. So this is you need to remember. If you remember this, everything will be easy for you. Okay, so sine, if I say reciprocal or inverse, it will be cosecant theta. Okay, and if I say cos of opposite will be secant theta. Okay, so this is how you go inverse when I talked about cosecant and secant. Okay, same as with this tan, if I say tan equals will be cot, so it will be very much easy to remember. So this is how you can go. Okay, so this is done. So right now, so you already know this import thing. Okay, so we first try to read these things and show you what is some of the things we will try to take, some of the functions, some of the symbols, and try to get. Okay, so first of all we will go with exponential. Okay, so if I say if I'll go with the if I'll say print e to the power x, so in input wise, if you refer this impy library, if you want to go with exponential e to the power x, this is the way you have to go. Okay, so if you are printing e to the exponential x, it retains the, okay, so to consider symbols you have to go this way, x, y and z. Okay, and symbols will be x, y and z. Okay, so if I say this exponential, so e to the power x, and if I say I need to differentiate this e to the power x, okay, so we will get the value. So we'll try to check. So it will retain the same. So e to the power x, if we differentiate, it retains the same. So our print statement e to the power x remains same, and same as with these things. Okay, now I try to plot this stuff. So this is what we got. Okay, so this is what we got, the plot. Okay, so it started from negative, so you can start with a here and then you try to reach upwards. Okay, so this is how we receive our exponential graph. Okay, so one more thing which we go, is we try to differentiate the log x. Okay, so we got the plot, and if we try to print the log x, if I try to print, it will retain the same, but in differential we will definitely gonna get some other things. So we will say log of x. Okay, so we'll first print and see what is differentiation of log x. So it should be 1 by x. Okay, we got the plot, that is e to the power x 1 by x. Okay, so our differentiation is working. So we'll try to plot this log x. Now what happens, there is a relationship is there. The graph of e to the power x exponential is inverse of our log x. Okay, maybe we got this way we can't see the value of this one, say differentiation. Okay, I try to plot this log x. I think I got the differentiation, so it plotted entirely different. So we'll try to plot the log x, and since e to the power x retains same, so we didn't get any problem, and log x we got differentiation. So that's how we do. We'll remove the differentiation part here as well. Okay, so this is how we get to know about this exponential and log x, since it will be inverse. Okay, so this is how, see, exponential, if you go, it will be try to move upward. So it is when we try to approach this one, it is like when it is getting negative, it approach x negative values. Okay, and when we got to logarithm is exactly approaches phi negative value, and certain things from the x value it will get in a positive. So if you try to plot at the same time, it will be an inverse of this one. So this will be like we're trying to get this e to the power x, and same as with the log x, so inverse will be there. So you just try to find it out. So exponential and this log x is very much important, so please do consider this. As I was talking about the our sin x, so it is very much necessary. So we'll try to plot it this sin x first. So we'll directly see our sin x. Okay, so this is sin x. Now what happens, our sin x is like if you go with the sin 0, the value will be 0. Okay, so this is how we get to know about our sin x. I'm gonna discuss in deep. So as for now, this will be, you can call as an initial start. So please do get to know about this sin x. So you get to know about this and is a periodic function as well. Okay, so this is how we plot the sin x. And if we get to know about this cos x, so it is inverse of cos x. Okay, so this is how we get to know, and I can show you in differentiation as well. Okay, if I differentiate this sin x, differentiate the sin x, we will definitely gonna get the cos x itself. Okay, so if I say plot you already seen the cos x, plot the cos x graph. So if I try to differentiate, we'll get the same cos x. So you get to know that differentiation of sin x will be cos x, same as with this one. If I try to plot cos x, if I print as well, okay, I will try to print this thing as well. So it will be like minus sin x. So this is minus sin x. Okay, so this is the differentiation we get. Since if I'll go with the same these things, this is how we get the value. So this is interrelated and inverse. So each and everything will be related. So please do follow, and